Have you ever wondered why we can't travel faster than the speed of sound on commercial aircraft? Well, to answer that, first we need to understand the speed of sound itself. Sound, in dry air at sea level, travels at approximately 767 miles per hour, or 1,235 kilometers per hour. But did you know that this speed isn't constant? It actually changes with temperature and atmospheric pressure, a fascinating quirk of our natural world. On a hot day, sound travels faster than on a cold one, and at higher altitudes, where the air is less dense, it slows down. Now let's briefly touch on Mach numbers. Named after physicist Ernst Mach, a Mach number represents the speed of an object traveling through air divided by the speed of sound. So when we say something is traveling at Mach 1, it's moving at the speed of sound. So now we understand the speed of sound, but why can't our airplanes match this speed? On the surface, it might seem like a great idea to have planes that can outpace sound, but there are a few roadblocks. First, let's consider the physical stress on an aircraft traveling at such high speeds. The friction caused by the air molecules hitting the aircraft's skin can generate a significant amount of heat. This could potentially cause structural damage or even compromise the safety of the flight, especially on long-haul journeys. Then, there's the impact of breaking the sound barrier. Ever heard of a sonic boom? Well, this is the thunder-like noise an object makes when it travels faster than the speed of sound. It's not just a cool phenomenon to observe, but it can also be disruptive on the ground, causing distress to people and animals, and even damaging buildings in extreme cases. Economic factors also come into play. Traveling at supersonic speeds requires a lot of fuel, which means higher operating costs. And while the idea of getting to your destination in half the time is definitely appealing, the reality is that there's a limited market for such high-speed travel. Not everyone is willing or able to pay the premium price for a faster flight. So while technically possible, supersonic travel on commercial planes has a host of challenges that make it impractical and economically unfeasible at this time. To recap, the speed of sound isn't a barrier we can't cross, it's a barrier we choose not to cross. The speed of sound, clocking in at approximately 768 miles per hour, is a measure of how quickly pressure waves, such as sound, can travel through a medium like air. However, as we've seen, moving faster than this speed brings with it a whole host of challenges. Firstly, the physical strain on aircraft flying at supersonic speeds is immense. The increased heat and pressure can lead to structural damage over time, not to mention the sonic booms that can be disruptive and potentially damaging to structures on the ground. Secondly, the economic implications are significant. Fuel consumption increases exponentially at supersonic speeds, making it an expensive endeavor. And while faster travel times might seem appealing, the potential for increased ticket prices to cover these costs could deter many passengers. Lastly, there's the environmental impact to consider. The greater fuel consumption means more greenhouse gas emissions, contributing to climate change. And let's not forget the noise pollution from those sonic booms. Taking all these factors into account, it's clear that while we have the technology to fly faster than the speed of sound, we choose not to for the sake of safety, affordability, and sustainability. So next time you're on a flight, remember, going slower than the speed of sound isn't a limitation, it's a choice. One that ensures your safety, comfort, and the sustainability of commercial aviation.